Hi everyone, welcome back to AI Unfiltered. I'm your host Mamta Suri. I'm joined by Dr. Eric Daimler. Dr. Eric Daimler is a fellow CMU alumni and he is a recognized authority in artificial intelligence. Today we'll be talking about everything from the different AI use cases and industries, using Neuro-Symbolic AI, what it is, having trust in AI systems, achieving AGI, which is a question on everyone's mind, and a sneak peek into his book, The Future is Formal. So let's get started. Eric is a recognized authority in artificial intelligence with 20 plus years of experience as an entrepreneur, executive, investor, technologist, and policy advisor. He has co-founded 6 tech companies. Currently, he is the CEO, co-founder of Connexus AI, a next-generation hybrid generative AI platform for trustworthy and fast digital modernization. And he's the author of forthcoming book, The Future is Formal, the roadmap for using technology to solve society's biggest problems. Anything I missed, Eric? That's quite an intro.
That's kind of you. Thank you. It's good to be here.
Eric, can you share some real-world examples of how AI is currently being used in various industries and what practical benefits these applications are bringing to these organizations?
Yeah. The place I often look is in the deep infrastructure for critical applications. Everybody knows about the popular applications of creating draft of an email or having it review some writing for potential tone and intent. But where I focus is in making sure that things like power plants operate or that we have an electrical grid that is more efficient. So, one example is in designing an airplane. Connexus AI software as a generative deterministic AI, a symbolic generative AI, is deployed at one of these large commercial airplane manufacturers, and the engineers' models of a fuselage, the engineers' models of an engine and of a wing. You can imagine that there are very specific tolerances that are designed by the engineers for each of these components of the airplane. And one of those tolerances might be vibration, for example. Today's efforts of building an airplane have the engineers, quite literally from different parts of the organization, manually, we'll say, negotiate the interpretations of the models and those tolerances for vibration to come up to a resolution about how to accommodate the intersection of those components, the wing of the airplane and the engine in this example. What often happens is that tolerances then just give way to a degree of error that's built into adding extra weight to the airplane with concomitant costs and a schedule extension. How much better is it to have an AI input all of the models from across the airplane's design, in this case, from the fuselage, from the engine, from the wing, and the AI reconciles the overlap of the tolerances of vibration. It can, be the vibration of 5 plus or minus 1 versus a vibration of 6 plus or minus 2. How do are those additive, or do they cancel each other out? The AI can reconcile that, the outcome of which is to reduce waste, reduce the excess weight of the airplane, shrink the schedule, and therefore shrink the cost, while actually improving the integrity, because you can have provable results down to the level of mathematics for the end result, the ultimate composition of the model of the airplane, versus today, which is what you do is compose those using manual efforts with humans that introduce the errors naturally, because we're all human, and then test and fail and test and fail until you're satisfied that at least that level of failure is rare, but not non-existent. So the benefit here for AI is an improvement in speed, a diminishment in cost, an improvement in integrity, and that benefits everybody.
Comparative to how it is done today and where we are going with this AI, it's a very, very relevant example, taking care of safety, reducing costs, reducing time, reducing manual errors. How far do you think we are from that point?
Well, we're deploying this today. There are thousands, tens of thousands, different applications across the world where this needs to get deployed. And all too often, these applications are still done manually. This is a $50 billion industry just reconciling data from these increasingly large and complex systems across the world, and in every industry, from logistics to manufacturing, as we just described, to energy, to defense. We want to deploy in all of those organizations. It's going to be very disruptive in one sense because the people doing this kind of vocational level work today will move into more interesting work. But for all the rest of us benefiting by the output of this increased digital infrastructure, the increased integrity of this digital infrastructure, we will be safer and get better results more quickly as a result of the deployment of the software. To use another example, the energy grid, right now demands people looking at data stored in databases. These databases need to be reconciled to some extent. And they need to be reconciled, not just across the different sources of energy, whether it's hydroelectric power or solar power or some fossil fuel legacy system, but also across the vendors that will enable those different power systems. So you could have one vendor for one type of windmill and another vendor for another type of windmill. There are 5 different major windmill manufacturers that you and I just care that we have, a cold drink and a warm bath. The electrical grid has to concern themselves with how they get that power to us. The benefit of having an AI be applied to the consumption and integration of all of those databases results in reduced waste, increased efficiency of the power grid. So you keep less energy in reserve wasted, generating excess fossil fuels. You're able to better predict, better use the resources available already in the power grid. So this is another benefit of having AI applied deep in the infrastructure of our existing electrical grid. The increased speed, reduced costs, and increased integrity, reducing waste of fossil fuels in this particular case.
I would love to have that in my area because every year, it doesn't matter the season, we go through rolling blackouts. I'm in California. So, and I hope this AI technology could also be applied to our water use case because water is another constraint in California where it's hard to predict the rains, how many rains are we going to have, what is the level of the lakes, and how they're going to monitor the water usage, how the temperatures are going to be. So yeah, definitely, I think for all of these industries, it's going to be very disruptive, but also very beneficial for the users. Now let's take a look at the flip side. So what are some of the common misconceptions or myths surrounding AI or the dangers of AI that people don't want to, just because although we can see the benefits, they are a little bit skeptical about deploying these solutions?
Yeah. What's funny is I think that people often don't trust automated solutions in general. They sometimes will just trust somebody if they personally know them to make these errors because systems can often be black boxes. I'm reminded of the old example. The well-known example was the reason that elevator music becomes elevator music was because people were frightened to get in the elevator when there wasn't an operator physically in there with you. So we get music to coax us in. Today, we drive in autonomous cars. So, often to my office today, I took a Waymo autonomous car, and inside those Waymos, what I've noticed over the year or so, I've been using them more regularly. My first ride in an autonomous car was 2016. Waymo has introduced elevator music, essentially. And so about 4 months ago, they introduced music as an option, but about a month ago, they introduced music without an option. I just get in the car, music's already playing, and it just reminds me of the elevator and elevator music, so people can feel more relaxed about being in a car that's driving itself with nobody in the front seat. So I think the misconception is just the degree to which we can trust these systems that are automated, that don't have where you don't see people pulling levers or you don't see people manually manipulating data. That's a misconception that I think impairs adoption or certainly unjustly reduces trust.
It's very interesting you gave the example of elevators today. We're not scared of elevators at all, but I can totally imagine when it first came out, people were hesitant to get into it, just like I'm hesitant to get into even Waymo because no one is driving it. And that feeling of trust for me is not there yet. How do you think people in AI can obtain this trust? Is it just timing or are there any other things?
Well, I think to some extent, just like elevators, time with these systems will give us more comfort. But often there'll be some amount of people that may be hesitant. Air travel is well known as a statistically safe way to travel, relative to people driving their cars. And yet people can reasonably or unreasonably still have anxiety around being in airplane. So that can happen regardless. But I'm reminded of this time where I ran a statistical arbitrage hedge fund, financial trading firm. We used math and only math, but we couldn't, and no matter how much we explained the math, really get people to trust what we were doing. Without the same level of math understanding that we had, would often not be comfortable about the degree to which we were just selling insurance. And the nature of selling insurance is you can be collecting premiums on insurance. So, collect $100 a month, collect $100 a month, collect $100 a month. But then as soon as I have a claim against somebody has a claim against their insurance policy and I could pay out $1 million and then my insurance company goes bankrupt. So nobody knew whether we were selling insurance. We were making money every month with our statistical arbitrage hedge fund. But if you don't know the math behind it, or you don't trust the math behind it, nobody can trust it. The way we got over that was you just do it for a long enough period of time in different environments. You do it in cold weather, do it in warm weather, you do it in really hot weather, do it in really cold weather, do it figuratively, then people will begin to trust it. And that's probably what's going to end up happening here. We would like to additionally introduce the concepts of symbols or deterministic AI, neuro-symbolic AI. Neuro-symbolic AI introduces facts or deduction into the process of otherwise probabilistic AIs. And I think ultimately the future is going to be a combination of deterministic and probabilistic AIs. Neuro-symbolic is the term that's emerging. And that'll be the future that also can give people a little more transparency into the underlying AI infrastructures that we'll see in some of these more critical contexts, and hopefully give people comfort to their safety and efficacy.
I'm loving the analogies that you've given so far. And is there any analogy you can give regarding neuro-symbolic AI? This might not be as common of a word outside of the tech industry. What does it mean?
Yeah. Well, right now the telegenic AI is in large language models, and those use a form of logic. If we remember our middle school logic, called induction. And so if you remember induction, we'll say generically tops down, bottoms up. If you think of induction, you can think of, well, I've seen a swan that is white, and I've seen 2 swans that are white, and maybe I've seen 100 swans that are white. And somewhere in there, I can conclude that all swans are white. Maybe I could see 1,000,000 swans that are white, and I'll still say, well, I am really convinced that all swans are white. That's induction. As I tell the story, and I tell the story particularly with swans, you already know the conclusion that an anomaly can occur where I will be proof my inductive proof will be deemed to be incorrect. But that's the nature of induction. And that's what large language models do today. The opposite way, remembering our logic, is deduction. And that's a Sherlock Holmes approach. So the first Sherlock Holmes starts with facts. All animals that have wings, all animals that have wings are birds. This animal has wings, therefore it's a bird. That's deducting. Start with facts, ends with facts. That's deduction. So deduction, induction. The neuro is the induction part. The symbolic is the deduction part. You combine those neuro-symbolic. It's a unnecessarily fancy term, but you can say tops down, bottoms up. You can say a deduction, induction, but it's a way of introducing facts to the telegenic AI that we see popularized in the news, and everybody here probably uses on a daily basis today.
Oh, that's a very good way of explaining it. Thank you. Now I understand even better. It's the induction and deduction combined together, and therefore it's more powerful. The results that it's giving or the decisions that it's making are much more based not just on the induction models, it's also based on the logic and the reasoning and the proof based. That's very, very interesting. And can you provide some insights in how Connexus AI is helping businesses address the challenges that they're having in this neuro-symbolic AI, which are not easily solved by Gen AI or even predictive AI?
Yeah, Gen AI and predictive AI are all the same. You may trust it to draft an email, but you're not going to trust it to design an airplane or run a power plant or do risk management for a money center bank. I guess is another example. When when you want to have these queries across an increasingly large system, you want to ask questions of an increasingly large system. If you use just the probabilistic approach or the inductive approach, what we quite know is that today's systems can confabulate or hallucinate in the popular vernacular. Uh, uh, to come back with something that's not truth. And that's really the nature of those systems. Uh, you can put in nothing but truth into those systems and still get back not truth. That's a fundamental weakness. You might hear some people being religious about those systems, saying, "Oh, we're working on it; they're getting better." But foundational to those approaches is if you only use probabilistic models, you will leave some portion of your system vulnerable to failure. There are some systems in the world that we do not want to leave open to failure. One of those is the management of our financial system, including the management of a money center bank, a large bank. One of the clients of Connexus AI is this money center bank that uses our AI to accumulate and compose more of the data that they already have. They can't today bring all that data into their risk models using classical systems because the composition of them, the reconciliation of them, is maybe an easy way to say it, is just impossible because of its complexity. That you'd have to still resort to the testing of subsets of the data. So much better to have the AI consume all of the data, intake all of the data across this money center bank for the purpose of risk management and reconcile where, if any, there are logical contradictions that take place and reconcile tolerances and dependencies across that data. The impact here for our money center client from the deployment of Connexus AI software is a reduction in excess capital to be held in reserve. So it's an efficiency in this financial system that brings lower rates to its consumers and a better service to consumers and a more efficient and responsive financial system. So it's a result of AI being applied to a money center bank.
So speaking of data, one of the things with these models is that these models are good, whether they're induction-based models or reduction-based models, they're as good as the data that's being provided. And one of the challenges we have seen is there is not that much data available. So when we're talking about these financial system or large banks, we cannot even train them on any generic data. It has to be that specific. So what are your thoughts around having the right data, where to get the data, and training these models with this kind of data?
It's a limitation of probabilistic models with machine learning and the subset of machine learning neural nets that a great deal of data is required. There's certainly research today trying to reduce the amount of data that's required while still generating effective results from neural networks and the superset of machine learning applications for those purposes. But so much better is to just go to the facts of the matter, facts of the data in the symbols. And then for that, you do not need massive amounts of data. You need several orders of magnitude less data available just to represent the facts, because you're not training the model per se, you're just capturing the facts as their result. So they're really fundamentally different ways of looking at the data. You need the symbols, the symbolic part of the AI, just representing what you've already collected. And the probabilistic model uses data from the past. The benefits actually are that when you look into the future, if you have a probabilistic model, you will always be guessing. But if you use a symbolic model, the symbolic model actually can adapt itself to the data as it comes out. So there was a time during COVID where oil futures, for example, went to zero. It went negative actually. If you had a machine learning trained model, that would just result in an error, it'd be, dividing by zero. And this actually happened. Our largest energy companies were forced to just guess about how to plan their supply chain because the models broke. Had they been then deploying a symbolic algorithm, then the model would have adapted to the new reality of the data changing and the oil futures going negative, and conformed to the rest of the model's constraints already available to adapt the model that would have had a principled result. The oil companies ended up doing just fine guessing for a short period of time, but it's a fundamental loss of integrity from a probabilistic model in those particular applications. So anyway, that's the framing of the benefit of using either back-tested, backdated, trained models versus using fact-based symbol deterministic models.
Yeah, and going back to your analogy with the swans, this means that you get a data of 1,000 white birds and white swans, and you think maybe that's enough because all of them are white, so all swans are white, and then you get maybe 10,000, a million, and maybe you still don't get any anomalies in there, and you think that this is enough. With this kind of data, you don't know how much data is enough. But on the symbolic side, on the deduction side, then it's very, very fact based. You don't need millions and millions tokens of data. You go proof by proof or step by step. The Sherlock Holmes approach, I love that analogy, and only looking at the facts. And for those kind of reasons, yeah, you don't need that much data. That makes complete sense. And I don't see too many people actually right now in the AI field using this neurosymbolic approach. Maybe to get better results, we should start doing that more.
Yeah, this approach is done currently in quantum compilers. So in quantum computing, the compiling of those programs, quantum compilers, has to be done by type theorists or the related branch of mathematics category theorist. That's who hires all the type theorists is quantum computing companies to do their quantum compilers. Quantum compilers really would be uninterpretable by humans if it were not for the underlying mathematics that powers Neuro-Symbolic AI. Another area that already uses this technology is in smart contract on the blockchain. Those currently do not have military grade integrity, but there are smart people working on that program, that infrastructure like Hedera Hashgraph. And I'm confident that those people will be able to solve that problem ultimately. But those are two other domains that do use this applied to databases. Connexus AI is the recognized leader of applying neurosymbolic AI, and we're happy to be in that position.
AI, there are some risks that come as well. So, for our listeners, what are some practical tips or best practices that organizations can follow to put guardrails around either their models or if they're even adopting AI and making sure we're using it responsibly?
Yeah, it's a good question. A lot of companies are instituting policies for safe AI, but they don't have really any idea how to implement technologies to do this. It reminds me of a time when the United States recognized a certain cybersecurity vulnerability. We started training people in cybersecurity, but unfortunately, we over rotated on cybersecurity policy instead of cybersecurity technology. It's been identified by the U.S. Department of Defense that it's actually a critical risk, a critical vulnerability of the United States that we do not have a sufficient number of people graduating in cybersecurity technology. And it's it's an unfortunate circumstance to have misled all those poor people that thought they were getting a worthwhile degree in cybersecurity, but in the wrong part of that spectrum. That reminds me of what's happening today in AI. People are coming out of the woodwork thinking they are experts, but they're experts in prescribing the policies, not actually implementing them or managing them or ensuring compliance. To ensure compliance for these large firms, what they need to do is have a safe AI wrapper around what's generated from these large language models, which are known to confabulate or hallucinate. The wrapper would itself be checking for the accuracy of SQL queries, for example, or of Excel models or whatever you're asking the large language model to generate. If you're generating English, that's not really machine readable per se. So it's going to be much more difficult to be able to somehow judge whether that's accurate or inaccurate. A little bit like judging whether or not Java is accurate or inaccurate. You really want to have some higher level language like SQL or like Excel to be able to judge. So you'll start with some of these policies that define the compliance regime that needs to be adhered to, and then you'll apply this blanket of safe AI to make sure you're conforming to it. That's the nature of neuro-symbolic AI. That's what this sort of AI implementation will do, is ensure this compliance to a way that you can bet your career on, which is what ultimately people are looking to be doing, and they're implementing these software systems, making sure you don't crash your enterprise data system is something that certainly will have people's attention.
Yeah, that's definitely a risk that many companies are not even recognizing yet. Everyone wants to be fast in this AI race, and they want to do something with AI. It's similar to, when SQL came around, it was very powerful, but then we had SQL injection. We had, when internet came around, we had DDoS attacks and man-in-the-middle attacks, like cybersecurity, like we doubled down on the policies rather than the technology. We are at the same kind of cusp right now, and we are now seeing prompting injection attacks. So it definitely needs to be thought out. And I think it needs to be done at different levels. Definitely, it needs to be done at the government level, but they're also trying to catch up because this has just been accelerated with Gen AI. At the companies level, the companies need to have policies and guidelines, and like you mentioned, some guardrails around it. And then also at the end user level, we as users need to be also mindful of what we are sharing and how we are sharing with. And we always say that nothing on the internet is all ever gone. And now we are giving our data, like our pictures, our personal data, even emails, right? And you mentioned about compliance. Eric, can you touch a little bit more on that? How can companies ensure compliance with the different industry regulations?
You've guaranteed compliance, starts with the defining it in a really specific way. And we got to determine whether or not we are concerned about compliance, your own risk models within an organization, or some government compliance. Did you define the terms of this compliance, or were they given to you? One of the places that we were deployed was working with this Fortune 50 company that had risk models, cybersecurity risk models throughout their organization. They wanted to make sure that they were arguing in a principled way about the budgets for their cybersecurity to ensure compliance around their cybersecurity constraints or their cybersecurity exposure. Currently, they had at the leadership level just argued in English about whether 13 million should be put here against some risk and 40 million over there against some risk. So it's not a terribly principled way of having that discussion. Again, how much better would it be? Have the AI be able to provide value here to have a more educated conversation? And that's what happened. The department heads would be giving risk assessments of their individual cybersecurity risk across this very large organization. And the AI was able to bring all those models, quantified models, all together, map to a risk framework. In this case, it was FIRE, I think it's FHRE, if I recall correctly, mapped to this risk framework that was also supplied by the client. So you had a composition of different mathematical models from the bottom of the organization. This was bottoms up, mapped to this risk model that then would give a principled output to the leadership to have a discussion where they then could, in a much more, I'd say, principled way, but you can also say just informed way, because it was really based on fact, not feelings, for the allocations of budgets to mitigate against cybersecurity risk. So this is one way of talking about compliance or adherence to compliance, which is adherence to their own concepts of principled addressing of cybersecurity risk. And this is enabled by only an AI. Today, that would have happened, just would have collapsed. That it would have really happened. It collapsed manually because the complexity of aggregating all of those different views is just too much to handle, too much to scale. So you just have floors of people in high rises trying to coordinate with themselves about what these different departments mean until you're not quite sure if the game of telephone is in play for the ultimate result that wound up for leadership making a decision. And maybe my wife get frustrated sometimes around large organization decisions because they seem to not make much sense. But the AI can help mitigate that because the facts are communicated, quite directly from the people on the ground to leadership, then making allocations or decisions of allocations of resources.
Yeah, I like that analogy. It's not a game of telephone anymore. It the message that you send from the starting point is exactly the same as the ending point.
Beautiful, it's beautiful technology.
Yeah, very well said. So as we look towards the future, Eric, in your opinion, it's like this technology has been, of course, AI, ML has been around for a long, long time. But with Gen AI, it has just accelerated so much and it has become a common, phrase that all of us are using now. So there is a lot more focus on it, a lot more people are working on it now. So it's continuing to evolve rapidly at a much faster pace. How do you see AI playing in shaping the future of our industries, of our companies, and our society?
I think that we all will want to be experimenting, in my case, multiple times a day with the different generative AI technologies that we see become available in the world. I notice improvements in these generative AI technologies, if not day to day, then, week to week. And I notice differences between these different technologies. They actually enable not my own experimentation, but my own concept of maybe what's possible and when it's possible to be using these different technologies in combination. This skill really to be developed among all of us. You, me, all the people watching and listening to this is the practice of diminishing ambiguity. That's the issue. That's really a skill that many engineers and lawyers and accountants have in a particular domain, but all of us can get this. Even people that are really, and maybe especially people that are trained with words, understand when they're being clear. But we can all discipline ourselves to distinguish when something we read is unclear and when we're saying something that we write is unclear. Ultimately, where we're going to want to get to is being more clear, that we will evolve to becoming ever more precise in our language. Lawyers going to be a little more like engineers. Engineers will be even that much more producing material that can be input by machines. And that's going to be a cycle of different areas of our world becoming more precise, getting automated by machines, and then that's moving on to another domain. This automation acceleration is I think what we're going to experience as an improvement in our lifestyle because of an increase in productivity. But the daily experience of us will be all of us participating in the automation of many tasks, many parts of our world. That's how AI is going to show up, and the more we participate in this and get facile in that whole sequence, the better off we will be as individuals.
Very well said. Eric, can you tell us a little bit more about your book? It's very interesting title to begin with. The Future is Formal, the roadmap for using technology to solve society's biggest problems. First of all, which biggest problems are we talking about? If
They're friends. I tell you, it's a little intimidating writing a book on AI because the publishing sequence is such that I have to make sure whatever I'm writing, I'm not going to be embarrassed about 2 years from now, when it actually, comes out. And that's really getting at this concept we were just talking about, which is that we are, we are looking back in order to look forward to these places that we have introduced formality in our lives. The biggest example is around really the Industrial Revolution and the introduction of an assembly line, where those initially were just sequences of people in a line doing what artisans had previously done, but in a routinized sequence, so that we could increase the throughput of any particular thing in operations. We would specialize on a particular task, whatever it was. It could be making hubcaps for a car or some other sort of process. And those little specialization began to then be automated by machines over time. We're going to experience that same sort of sequence today, but in a digital environment. We see it today. Little by little, we will have, not just spell checkers or grammar checkers, or now we have the 32,000 word autocomplete with LLMs. We will have what this one HR company says I could push a button when I hire somebody, and suddenly their email gets created, their 401k gets created, their security protocols get clearance into our building. That's an automation sequence where not so long ago, somebody would have had to create each one of these things manually, but now I got to push a button. It's a simple little example of automation in daily life, which is really a collection of things that also have been automated. That's the world we're going to be living in. That's the formality that we're talking about, and how we participate in that is by working to become more specific in what we do. The big result of this is that the super application for AI, the killer app for AI, is massive collaboration. That's where it's all going.
Mhm.
These large organizations, the largest of the organizations you can imagine in the world, really exist. They're we'll say allowed to exist because of the efficiencies required in extra extra complex systems coordinating with themselves. Entire floors of high rises in central cities are populated by people that are coordinating internally in various capacities. If we are able to formalize our own work in order to make it so much more specific that it can be read by a machine and then communicated to other machines, the future large organizations, if you can call them that, will actually be networks. And you can have these massive networks of people that will simulate the largest organizations today. We will have many, 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 many smaller groups coordinating in moving flexible networks of groups in to handle a particular operation that synthetically recreate the largest organizations today. That's enabled by the scaling of this very specific machine readable expert controlled, this is kind of human expert control input. That's where the future is going. And that's what the futurist formal lays out and works to present.
I like the part about the human expert control, because we definitely want the control to still be human, which actually brings me to my next point. What are your thoughts on AGI?
This term of artificial general intelligence is really more. It meant something different, as AI has. When I started my career, 20 plus years ago, it's become a marketing term. I think it's a little bit like saying full self-driving car. I don't know how relevant it is to any of our daily experience, but it may not matter how relevant the term is. It's just that these systems become very, very smart. And if they can simulate intelligence, that's enough for us to do a lot of things. There's a lot of things we can do, regardless of whether or not these are truly conscious or they're simulating conscious.
Yeah, I would like to believe we are very far away from that. I'm an optimist.
We can say what we believe. I think that the consensus is this is unlikely among scientists, not among marketers. Or those people who would have an axe to grind, or a dog to the hunt, or whatever the metaphor you want to use. I think the consensus is this is very unlikely to happen in the next 20 to 30 years, but it really may never happen. I say more. There may be some. I'm convinced that there really is something magical in consciousness about our own bodies having both a brain and a nervous system. And it really is in the combination of the probabilistic brain and a deterministic nervous system working in unison that creates a degree of consciousness. So that the conclusion being true consciousness, we probably will find will ultimately be represented by something that has more of a biological component than anything resembling even NVIDIA's fanciest semiconductors, times a billion.
Yeah, I like that even more, that it's unlikely. Consciousness is very magical. That's what you said, Eric. And we ourselves don't understand it completely. So if we don't understand it, how can we code it? Someone needs to code it. Thank you so much for your time. Eric, anything else you want to add before we end this?
No, this has been a good time. This has been a good time. Yeah, Connexus.com and, Eric Daimler on LinkedIn. And you can also check out my wife's book on corporate culture, Reculturing Melissa Daimler. It's how to operationalize corporate culture. It's not
Mm,
just about the ping pong tables.
yeah, no, that's another one of my favorite topics. Thank you so much,
Thank you very much.
Eric,
Thanks.
and thank you so much for taking the time.